Hello everyone. We're going to talk about linear relations. In particular, we're talking about table of values and completing the table. Specifically, we're going to talk about table of values and completing the table. So when we have an expression, something like 2x plus 1, y is equal to 2x plus 1, what we can do is we can substitute in a variety of different values for x. And we need to remember to use BEDMAS rules when solving. So the first example here, we've chosen all these values to substitute in for x. And the next column here shows what we've done. So y is equal to 2 times negative 3 plus 1. So 2 times negative 3 plus 1 is equal to negative 5. So when we put in negative 3, which is our input, the output is negative 5. That's what happens. Now the ordered pair you can write in order, negative 3, negative 5. The next input value that we choose is negative 2. So 2 times negative 2 plus 1 is negative 3. So our ordered pair is negative 2, negative 3. Okay. Our next one is negative 1. So 2 times negative 1 is negative 2 plus 1 is negative 1. So our ordered pair is negative 1, negative 1. Okay. The next one, we choose our input value of 0. So 2 times 0 is 0 plus 1 is positive 1. So our ordered pair is 0 and positive 1. Next one, 2 times 1 is 2 plus 1 is 3. So our ordered pair is 1, 3. 2 times 2 is 4. Sorry, we're on the next one here. Plus 1 is 5. So our ordered pair is 2, 5. The next input value that we're choosing is 3. So 2 times 3 is 6 plus 1 is 7. So our ordered pair is 3, 7. Here's our next expression here. So y is equal to x minus 7. So again, we choose our input values, everything we're going to plug into the equation. This next column shows what that looks like. Then we need to figure out the output values. So negative 3 minus 7 more is negative 10. So if we put in negative 3 into the expression, the output is negative 10. So our ordered pair is our x value of negative 3 and our y value, our resulting y value of negative 10. The next one here, we put in negative 2. So negative 2 minus 7 more is negative 9. So our resultant ordered pair is negative 2 and negative 9. The next one, negative 1 minus 7 is negative 8. So negative 1, negative 8 is our ordered pair. 0 minus 7 is negative 7. And you can start to see a pattern emerge here. Okay. Over here in the ordered pairs, negative 3, negative 2, negative 1, 0. That's exactly what our input values are. Now this is just going up by 1. So we can predict our next ordered pair is going to be 1 and negative 6. And then 2, negative 5, and 3, negative 4. And these would be negative 6, negative 5, and negative 4. And you can check your math there, but once you start to see a pattern emerge in the ordered pairs, you can predict what's going to happen. Okay. The next one we have here is negative x plus 14. Now I didn't put the table in because you're going to see a variety of different models, and you have to come up with something that works for you for organizing everything. So if our expression is y is equal to negative x plus 14, what we need to do is put in our first input value. Okay. So we have negative, and our first input value is negative 3. Now this negative makes that positive. Negative times a negative 3 is positive 3 plus 14. So our resultant output value is 17. Okay. So let's do the next one here. Negative times negative 2 plus 14. Negative times a negative 2 is positive 2. That becomes 16. All right. And the next one here is negative 1. Negative times negative 1 is positive 1. Plus 14 is 15. And you can start to see what happens here. This can be 14, 13, 12, and 11. So then you can write ordered pairs. Negative 3, 17, that would be an ordered pair. Negative 2, 16, that would be an ordered pair. Negative 1, 15, that's an ordered pair. 0, 14, that's an ordered pair. 1, 13, that's an ordered pair. 2, 12 is an ordered pair. And 3 and 11 is an ordered pair. That's this table, just written in XY form. Last example here, y is equal to negative 3 times x. That's our expression. So you plug in your x values. So the first one that we're choosing is negative 3. So negative 3 times negative 3 is positive 9. Okay. Y is equal to negative 3 times negative 2 is our next one. So that's positive 6. Y is equal to negative 3 times negative 1. That's our next one. That's positive 3. And you can start to see what happens here. That's going to be 0. That's going to be negative 3, negative 6, negative 9. Okay. And you can write all of these as ordered pairs as well. Just remember that it's in XY form. So you take the x value, negative 3, and the corresponding y value. There's an ordered pair. You can take any x value, and as long as you're writing the corresponding y value, that's an ordered pair.